This video is about piecewise functions, but before we define the term, we'll look at some examples. Let's say you have a cell phone data plan that includes some set amount of data. You don't have unlimited data. So you pay your set cost, the same regardless of how much data you use, up to a point. After that, the carrier charges you per megabyte of data you use at a constant rate. You could theoretically use as much as you need, but the cost goes up. The price you pay is a function of the data you use, but the function rule changes when you hit your prepaid data limit. Let's look at another example. You're going to buy some item, maybe some swag to promote your business, and so you're going to buy it in bulk. The manufacturer charges a set price per item, but if you buy enough, say 100 units, the price goes down and remains constant per unit for a while. But then you hit another number, maybe 1,000, the unit price goes down again. And since that price it doesn't give the manufacturer much margin anymore, that's as low as they're going to go no matter how many units you buy. These are both examples of piecewise functions. A piecewise function is a function that has different output rules for different parts of its domain. So more terminology. A function is continuous if you can trace its graph without picking up your marker. It is discontinuous if there are any breaks or holes and you can't trace it without picking up your marker. Another thing about the terms continuous and discontinuous is that they don't specifically describe piecewise functions. Most of the functions you've studied so far have been continuous, and some piecewise functions are. Keep in mind that continuity is what happens in the middle, not the ends. The first function on this side is discontinuous because there's a gap in the domain, but it does continue off to infinity in both directions. Some discontinuous functions can be defined with one rule. This step function, for example, takes a number and rounds down, ignoring anything after the decimal point, like we generally talk about age or grade level. Again, keep in mind that discontinuities are about breaks in the functions, not about whether or not there's an arrow at the end. This is an example of a piecewise function. This is defined differently over different parts of its domain. So if we wanted to know what f of negative 5 is, first we need to ask ourselves, which domain does negative 5 fit into? Is it less than 3? Is it less than negative 3? Is it between negative 3 and 1? Or is it greater than 4? And negative 5 fits into this category, so we're going to use this rule. We're asking about f of negative 1. We're going to ask ourselves, where does negative 1 fit in? Well, negative 1 is not less than negative 3, but it is between negative 3 and 1. So we look here to see what our answer is, and there's no actual place to put the input. Everything from here to here will just be 4. So there's no work to be done. This function tells you what the answer is because the input doesn't matter for this part of the function. Next, if we want to look for f of 2, 2 is not between negative infinity and negative 3. 2 is not between negative 3 and 1. 2 is not greater than 4, so 2 is not actually in the domain of this function, so there is no output corresponding to 2. If we're looking to graph a piecewise function, we're going to look at each individual equation separately, but just graph it on this domain. So this is going to be less than 0. So the y-intercept is 1, but it doesn't actually get to be that point. So I'm going to put an open circle there, and the slope is 2. But only because x is less than 0, we're not going to graph the line on the right side. We're only going to graph it on the left side. Next, between 0 and 2, the function is negative x plus 1. So the y-intercept is 1, which means we get to fill in this point, but only because this function allows us to. This function would not allow us to fill in that point. And then we're going to have a slope of negative 1 all the way until x equals 2. We're not going to graph past that point. And it is equal to 2 there. So I'm going to put a dot there as well. Now beyond 2, we're looking for x minus 1, which means that the y-intercept is -1, and the line has a slope of 1. But again, we're only going to start graphing it after 2. Does not actually equal at that point, and we can continue going up there. This function is discontinuous because while we can trace this part without picking up the marker, we have to then jump to get to this point here and continue along. Lastly, let's look at this graph and see if we can write a piecewise function for this. Now, it looks to me like this has 3 different parts. There's the part that ends at -4, there's another part that picks up at -4 and goes to 2, and another part that continues from 2 until 6. So I'm going to pretend that these are different functions and break them up, treating each part separately. So we're just going to look at this part. This line appears to have a slope of 1/4. And if we were to continue this line across, we would find its y-intercept is 2. But this function is this only when x is less than or equal to -4. The second part of the function, we can easily read the y-intercept there, and it looks like the slope is 1/1. So this next part would be 1x plus 2. But this rule only applies for where x is greater than -4 and less than or equal to +2. The third piece of this is just one constant output. Regardless of what the input is, the answer is going to be 4 because this graph has a height of 4 from 2 until 6. Now, this has an open circle at 6, so I'm not going to include the or equal to. I could include the or equal to here, but I've already put 2 in the domain for the second line of the equation. So I don't want to also include 2 in the domain here. That said, I didn't need to put the or equal to here. I could have put it here, but we don't want to double dip. We don't want to have an input that has a choice of which output rule to follow. And I'm going to put a bracket around there and say the function equals this rule. Thanks for watching. I hope you learned something about piecewise functions.